Alright, this is video 1, and this is over Pythagorean Theorem, and this is for geometry. So first of all, Pythagorean Theorem can only be used with right triangles, okay? And one of the ways that we can see that it's a right triangle is that it's got that square in the corner. That shows us, that mark there shows us that it is a right triangle, okay? Now, A and B, we call those our legs. Okay, those are the two sides that form that right angle. And C is the hypotenuse. Okay, it's our longest side, and it's across from the right angle. Okay, and so let's go ahead and add that it is the longest side. Okay, so it's always going to be directly across from that right angle. All right. So a couple things just that we're going to review over the Pythagorean Theorem is just the steps for it. All right, so first we're going to make sure that we label the longest side as C. Okay, so back to our picture, that's going to be C. It doesn't matter which sides you put as A and B. Okay, and then remember our formula. A squared plus B squared equals C squared. Super important. You guys have seen that for quite a long time now. So we're just gonna move on and go into a couple examples. All right, so for this first one, we're going to find the missing side, okay? So this is our longest side. We're gonna label this C, and it doesn't matter if this is A or B, all right? So we're gonna go ahead and get started. So this is 5 squared plus 12 squared equals C squared. All right, 5 squared is 25 plus 144 equals C squared. So we've got 169 equaling that. Okay, and we're not done yet. This 169 equals C squared. We just want to find the length of C. Okay, so when we square root both sides, we get C equals 13. All right, okay, moving on. Our next example, this is our C value here. We've got a leg and we need to find another leg, so let's just call this B. Okay, if you want to say X, you can do whatever you want. All right, so let's start. We've got 3 squared plus B squared equals 9 squared. Okay, solve for B squared, so rearrange it so that B squared is by itself, and then we can undo that square by square rooting. Remember, square roots and squares are inverses of each other. Now, 72 is not a perfect square, so you're going to have to do your little factor tree. Two numbers that multiply to get to 72 are 6 and 12. Two numbers to get 6 would be 3 and 2. Here we could have 3 and 4. And 4 breaks down even one more time to 2 and 2. Okay, remember we're looking for groups of 2. So here's a group of 2, our little 3's. And we've got a group of 2 here. All right, so our final answer would be that B equals, this would be 3 and 2, so 6 square root of 2. Remember, you multiply those two numbers. All right, and our last problem is using the distance formula, or find the distance using Pythagorean Theorem, which the distance formula is just the Pythagorean Theorem rearranged, okay? So first, all we have is a tree and a person. We want to find that distance. Well, it'd be kind of hard to estimate just counting, but we could count like this. Okay, we could use our Pythagorean Theorem, calling this A, B, and C. All right, so our A is 1, 2, 3, 4, 5. This side is 7, and we're trying to find our C value. So 5 squared plus 7 squared equals c squared. So 25 plus 49. So we've got 74 equaling c squared. Again, when we square root to undo, we're going to have to do that prime factorization. Now, two numbers to get to 74 are 2 and 37. Neither of those will break down anymore, so then we can just say that c equals the square root of 74. Make sure you always write your answer as a radical instead of a decimal, okay? If we typed in the square root of 74 into our calculator, we would get 8.6. Now, if I asked for an approximate, that'd be okay, but most of the time we want this exact answer. All right. Okay, so that's just our first lesson over the Pythagorean theorem.